Alright. And I think we are live. Hey everyone, FusionEd coming at ya, and welcome back to the weekly FusionEd Livestream. And this week we're going to be playing around with BLARP, and I have that running in the screen right now. And this was actually recommended to me by a Reddit user, Stewie Lai. Hopefully I'm pronouncing that right. But he basically just recommended I check this out. I'd never heard of BLARP before, and I was kind of surprised that I'd missed this on Steam. And when I checked it out, it was like really cool, and it's really simple. And let me actually go ahead, minimize this now. I just kind of wanted to show this to you guys, just to give you kind of a sense in case you hadn't seen this before. And I think this top review up here really summarizes BLARP pretty well. I mean, it's basically just saying like there's nothing like completely new with what BLARP does, but once you kind of get into it, you realize really quickly that this is designed specifically for VR, and you couldn't really play it in any other medium like mobile or PC, because one, you need that depth perception to be able to see where each of the baby blarps, I don't know if they're called blarps or babies, but you need to have that depth perception to be able to see where exactly they are in the space, which VR provides you. Plus, you need the hand controllers in order to actually control where the blarps are going and then do that flinging motion. So I really appreciate that review. I think it hits the nail on the head. And so, yeah, definitely really cool game. Excited to have found it and then being able to create a simplified version for you guys. And I think the other neat thing is if you go to Kabibio's GitHub page, it's actually available there. And I actually use some of the code here as a little reference just to make sure I got the physics right as far as like how everything feels. And I really appreciate that. It's super awesome that it is open source so that you can check it out. But I highly recommend, like, don't just go to this GitHub page and download it. Like, I highly recommend going to Steam and purchasing it. It's just a cup of coffee and really helping another dev out. That's amazing. So yeah, that's BLARP. And let me pop open the chat here. Yeah, cool. Hey VR World, how you doing? And let me go ahead and just pull open the very simplified version. Like nothing too fancy in here. And for the enemy or target, I guess, I put in just a red cube. Our blarbs are going to be just these orange orb spheres instead of the psychedelic colors. And I have this nice room, basically. And I'll tell you right now that one of the things that I noticed really early on in the development process when I was preparing for this, let me just jump into the Vive right now. But one of the things I noticed really early on was that actually probably the hardest part is not the flinging action. That's actually one of the easier parts of this. That he does do a couple of things to, whoops, weird things in this room when the tracking goes off. But one of the neat things is really the room physics. And to be honest, like simulating that is actually pretty hard. He puts in a compute shader that actually is, the code isn't available for that, which is completely fine. But you can get away with simulating something using Unity's built-in cloth engine. And I think that's really cool. So you can see there, just kind of bounces around. You can do it on the ground, you can do it on all of these. Oh, and I hit my target. And so, whoops. Here we go. Yep. So pretty basics of this game is anytime you hit that target, just like in BLARP, you get another orb. I didn't add any end state, so it's just going to keep growing and growing until we get bored. But in BLARP, it's if these guys come back and hit your controller, you're dead. Which, I mean, I think on the review, some people said that was a good thing. Others said it was not a good thing. I think something would be cool, and we'll see if we get to it in the stream, is adding a kind of like Snake, where you have a target that you always are going to, and then you then decide there are also like these bad targets that if you hit them by accident, then you lose. That could be definitely a cool effect. We'll see if we get there in the stream. But yeah, this is just kind of what we're working towards. So put that down. Awesome. Glad to have you, Andreas. So yeah, that's what we're building. And as always, what we're going to do is go to a new project. Let's call this BLARP Livestream 3D. And I'm crossing my fingers that it opens in 3D, not 2D. Pretty much every stream I do this, it opens in 2D. Okay, good. Hey, Xander, how's it going? How successful has BLARP been for you? I don't know if that's at me. Also, I should mention, in the chat, if you're directing something to me, put an @FuseMan in your description. That way it just helps me know that it's directed at me and I can see it in the chat easily. Because it gets lit in green for me. So yeah, so let's just kind of get started with that. And I think the first thing we want to work on is the cloth, basically. So we're going to start here basically with Unity's built-in plane, and then we're going to notice that there aren't enough vertices on it, so we're going to actually hop into Blender real fast, build a a plane with more vertices, and then import that in. So that's going to be a goal for implementing the room side of things. And again, that's like a simplified version of what was done in BLARP, because in BLARP he do a really nice job of like the actual effect of having, I don't even know how to describe it. It's I guess having the wall kind of bounce around and ripple out effect like that. I think is a really cool effect. A successful BLARP friend. Oh, I'm not the creator of BLARP. I think Cabibio is the creator of BLARP. Definitely a lot of cool works from him. If you check out his video, his intro video, like that is kind of shows a bunch of cool stuff he's made. And also on his GitHub page, he has a bunch of cool other projects, which I haven't checked out personally, but all the titles look cool. So there's that. And so yeah, let's go ahead and first play around with cloth. So the first thing we're going to want to do is create an empty game object. I'm just going to go ahead and put that at 0, 0, 0. And then we're going to add a component, and we're just going to add cloth. So there's a cloth component on this thing, but since we don't have a 3D model or mesh, we actually need to add that. And so you go into the skin mesh renderer here, and there's a mesh component or property, and you can go ahead and click plane for that. And it doesn't come in with a material, so we're going to have to add that. And I'm going to go ahead and create a materials folder and create material. Let's just call this wall material. And for now, actually no, I want to make this blue. Good enough. And we can go ahead, I'm just going to call this wall, and we just drag and drop the material we created onto our plane. And so now we have the plane in our world, and what we'll actually notice is I'm going to rotate this just so that I think it should be a bit more visible. 0, 0. And let's see. Assuming I did everything correctly. Oh, okay. First, I need to get rid of gravity. So on the cloth material, there's gravity. And the other thing I want to do, let me go to here. So when you create a cloth, you will, if you hit edit constraints, you will see all of the vertices on the cloth. And so we can, there are two modes. There's the select mode, and then there's paint mode. Select mode just basically lets you select the vertices you want, and paint mode lets you select specific vertices. We're gonna, just for testing purposes, I'm going to select these top vertices, and we're going to constrain them, which basically means that when the physics interacts with the cloth, it basically those are kind of locked in place. Or you can add, this is what the max distance property is, you can add a little leeway to get kind of a different type of effects, but for the most part it's basically kind of locked in place. So with that, assuming I did everything right, if we now move it, we get this nice little wavy effect, and it's flying all over the place. And it's like flying all over on top of itself. It's basically just, I think I moved it a bit too much, and so I just kind of rotated around itself. And like the thing with a plane is only one side is rendered, the other side isn't. So it's just basically rotating around that intersection line there that I kind of locked in place. So I mean, obviously with the room, if we want to get the full effect, we have to lock all of these side vertices in place. So to do that, just kind of lock, just select all these vertices, 2 in there. And the reason I'm doing 0.2 is from the paint tool, they recommend 0.2. You don't have to do 0.2. You can do pretty much whatever you want. Those are just kind of like terms to play around with. There we go. And yeah, so let's just try that out. And the transform, yep, there you go. And so yeah, so it's just kind of, it has that nice effect. And to basically now let's just kind of test and make sure that it's working when we throw like a ball or a capsule in between it. So to do that, we're going to go to game object, 3D object. I want a sphere. Just gonna drag this over here so that we make sure it's actually intersecting with the plane. And for now, I'm not going to worry about the properties. And the thing with when you want something to interact with the cloth, you need to do 2 things, or one of 2 things. Your interacting objects can only be a capsule or a sphere, and you have to declare them within your cloth. So we can go here and declare that we have a sphere that we want to interact with our cloth, and then we can just go ahead and drag that into here. To be honest, I'm not really sure why they give you 2 for spheres, but only 1 for the capsule. And you don't need to provide anything for the second one, so I'm not sure what the deal is. How I missed access, I didn't see them on the plane. So when you go to wall, and then you have your cloth component, you can hit edit constraint, and that will highlight, or it'll give you a list of, in black, all of these vertices here. So you can do one of 2 things, which is select them, which is just like left click and drag to select an area, and then all of the vertices within there are highlighted. Or you can individually like select specific ones like that, and that'll constrain them or edit their surface penetration. I'm going to, and of course now I can't deselect that. Let me unselect that there. There we go. So yeah, so that's that. Let me know if that answers your question. And so yeah, so let's go ahead and, oh, I guess speaking of that, like feel free to ask pretty much anything, like talk among yourself. I think these streams work really well if you like ask questions on your own projects and have either myself or anyone else in the community answer them, and just having a good conversation. Like that's the benefit, I think, of doing this live, is the fact that there are a bunch of you guys working together on cool VR ideas. So talk about that. I can chime in, I can help out here, pretty much ask whatever you want. That's, I think, the beauty of this. So yeah, with that, I'm going to go ahead and move the ball through the sphere. And there we go. It deforms. It's got a nice deform effect. I can keep going back and forth. You can move this closer to the top. Yep. Those live streams, you know it, every week. And so, yeah, we got the basics of the cloth without having to do all that much work. Not, actually, wait, we didn't do any coding. Yeah, we haven't even touched coding yet, and we can already deform a material. I think that's pretty cool, the fact that Unity provides that to you right off the bat. So there we go. And let's just go ahead. I think, so now what I'm going to do actually, we're going to hop into Blender. And if you've watched my streams before, you know I'm not a 3D artist. So Abdo is actually unable to make it today, and so he won't be in the chat with you guys. But he gave me these instructions, which I'm putting up on the screen for y'all, on how to use Blender to create a very simple plane that's medium poly, like higher than Unity's provided plane. And so we're going to create that, pull that into Unity, and that the more vertices you have on the plane basically allows you to have more control over what's constrained and what's not, and then you can get better cloth simulations. So I wanted to actually up the poly on it a little bit just so that we can get a better looking effect when you actually throw the ball through it. So I'm going to move this over here. And okay, so he said X to delete cube. So I guess I have to click here. X, delete the cube. Shift A to get the mesh menu. Yeah, I mean this stream was a suggestion, so definitely shoot either give me suggestions for future streams on Twitter here, Reddit. I'm all over the place. Just hit me up anywhere on the comments of this video. I look at all of them, so definitely let me know. I definitely have like a pipeline of a bunch of different things that I want to work on in future streams. Not sure how practical some of the ideas are. I have to figure that part out, but definitely hit me up on ideas that you want for future streams. That's for sure. I'm going to add the plane, choose mesh plane. Wait, no, I did that. Hit tab to go to edit mode. Hit W to get a special menu. Okay, and then we hit subdivide. So there we go. So I guess the plane originally is just 2 triangles, and I just have to do that multiple times. So subdivide, subdivide, subdivide. There we go. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Let's go one more. That should be more than high poly enough. So let's go ahead and save that as plane.blend, and I want to save it to I'm just going to save it to the desktop and then move it around from there. So, oh wait, there we go. BLARP Livestream, assets. Let me save it in here. Plane.blend. Save. So in theory, there's our plane, and it's untextured, but we can change that pretty easily. Can we give suggestion? What does Rabbit Hole VR do? Is it for Stanford students only? No. So Rabbit Hole VR is a club I'm helping out with at Stanford, and I mean, if you're in the area, definitely come hit us up. We had an event, what was it, 2 weeks ago, where we brought in a bunch of cool companies that were demoing. We had some amazing panels. Sorry about the audio on those. Unfortunately, the mic I had, I just bought it and it came the day of, and it was pretty quiet, unfortunately. But yeah, we basically just trying to create a community. Since we're all at Stanford, like it's full, like we're working with Stanford students primarily, but like definitely there are a lot of people outside of Stanford that are coming through as well, which I think is really cool. And so yeah, just trying to create people working on really cool projects, kind of like what I'm doing. So that's the gist of Rabbit Hole. So let me go ahead, and now that we have our mesh in here, I'm just going to quickly drag that in. You can see it's definitely a lot higher poly than our Unity mesh. Like if you compare the two, you can see a huge difference. So, like we're gonna have to scale this appropriately, but that's just kind of the gist of it. What's up, Eric and Hayukid? Hopefully I pronounced that right. So yeah, so now we have our wall in here, and or rather a mesh. And let me just pull up those instructions just really quickly. Yeah, so that's what Abdo sent me. So kudos to him for making this super simple on how we actually go to Blender and create a medium high polyish mesh. Actually, if I see, I can't see that here. Actually, can I see how many? It's about 1,000 verts, 2,000 triangles. That's not bad at all. It's bad if it were mobile, but for the Vive, that's nothing. Especially if this is like a super simplified version. So I mean, like polys are definitely something you need to be considerate of when you're building out any sort of mesh of any kind. But here, I think we're fine. On x64 system, does it matter if I download? Good question. I don't think it does, but maybe someone else can answer that better. My guess is it probably doesn't. I think the 32-bit is only if you have an old machine, which I don't recommend running VR on. But if you do, I guess you do. There's nothing stopping you there. But yeah, I would probably recommend the 64-bit, but I don't think it matters. And so yeah, now that we have the plane, I'm just gonna go ahead, delete that from here, and we're gonna go to our wall. And instead of the Unity mesh, I'm gonna go ahead. Where is it? Wait, where's the mesh? Was it this one? No. No. Wait, what in the world? Oh, whoops. I was like, where did my mesh go? And it was because I deleted it. And whoops, okay, I have to derp. I have to go make it again real fast. So it was X, delete, Shift A, plane, tab, W, subdivide, 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 subdivide. That looks good. Save it. Save to Blender. Okay. There we go. And now, okay, so now if I go into here, cube, there it is. And that looks right. And it, from some direction, I should be able to see it. Like, there it is. Okay. So yeah, so it is flipped backwards. So we're just gonna have to adjust that. Actually, maybe not. Nah, that actually looks reasonable. There we go. So I built something for cardboard. What vertices count should I aim for the models? Less than 2,000 for each individual one. For cardboard, and I think these specs will change with Daydream. I think Daydream in and of itself right now is very confusing on what to do. But I wouldn't necessarily go at the model level. I would think about your scenes. And for your scenes, you generally want to be hitting, I believe, a spec of like 50K to 100K triangles in the whole scene. That might be pushing it a little bit, but you just gonna have to be a little considerate of the number of triangles that you are putting in there. So like, like 2,000, I think, if it's just that model in the scene, then you should be fine. But if you have, say, 100 of those types of models, it could be a little expensive. So yeah, I would say it's on a scene by scene basis, not on a model by model basis. Like, if it yeah, it's kind of the way I'd summarize it. And like obviously, like the more vertices you have in there, like the higher fidelity it's going to be. Select in the hierarchy and press F. The scene viewer will zoom in to find objects you select. Yep. So yeah, so this is the plane. Since I changed the mesh, obviously all of our constraints are gone, so I'm going to have to go and select oops, I over selected. I'm going to select all of the edge vertices here, and I can't seem to do that properly. Yep, that looks right. Okay, cool. So I'm going to go ahead and make their max distance of 0.2. Same on the bottom ones. And same here. And then the last ones on the top. There we go. So now let's just quickly test that to make sure that worked. Where's the ball? Okay, the ball is ginormous compared to the mesh now, but that's fine. Oops. And yep, definitely works. And as you can see, there's a lot more effect on the whole mesh as a whole because of the fact that we've added a lot more vertices, so the clock physics has a lot more to play around with. And that we can play around with a bunch of these parameters to like change how much stretch occurs to it, but that's the gist of it. So yeah, so now I'm actually going to go ahead and scale the wall up just so that we get a bigger effect, or like it matches SteamVR, which we haven't even touched yet. So I'm going to make this a 5 by 5. I changed my mind. 5 by 5. That should be reasonable, I think. And luckily for us, this is all scaled according to Unity's units, because we're using a quad. We used a quad in Blender, which is, I believe, a meter. So that's super convenient. And so this is 5 meters by 5 meters, which for now, if we're talking a little bit about SteamVR, if your general population is using like 2 meters by 2 meters of a play space, well, even if we're going 3 by 3, like a 5 by 5 room isn't too bad. And again, that's something you can play around with depending on how much space you have. But like that's something to keep in mind when you're developing for something like the Vive and you have room scale as an option for people. So I'm going to go ahead and just set up our room real fast. So to do that, this is 270, 0, so that's going to be our floor. Can you not replace the low poly with the high poly mesh without creating a new one? Let's see, yep. So if you don't want to go into Blender and you just use the Unities, I mean, that's fine. What I noticed when playing around with it a little bit is you don't, especially when you scale things up, it doesn't look all that great. But like you definitely do get some sort of effect because the clock simulation is on there. Yep, yeah, you really do gotta love that. It's super convenient, and I think if Abdo was here, he would be speaking really highly of Blender, and I think as an open source project, it's really cool. So that's super awesome. And so yeah, let me just go ahead. This is gonna be our floor. This we're putting at 0, 0, 0. So duplicate that and here to like -5, and then rotate it up to this 0. Yeah, and just move this up by 5. Yep, there we go. And this is just going to be the left side. Actually, what I'm going to do really quickly is just create a parent object. Oops, wrong way. Just going to create a quick parent object just so that we know. Actually, I should keep these 5 by 5 so that we have the scale. Yep, there we go. Drag this in so that we just kind of group everything together so that we know exactly what's going on. I'm going to move this to the other side. Oops. Okay, I need to make it right. So that's right. And yeah, this is just kind of a tedious part, but you got to do what you got to do, right? Let's turn this around by 180, I guess. Make the X 0, Y is 1, and Z1. So that's left, right, and then we want front. We which is gonna be, I think, 0 here, 1. Okay, that's back. Whatever. Back, and then we just want to rotate that. Oops. Rotate that this way, which is, nope, not what I wanted. 270. Yeah, perfect. 270 for the back, and then for the front, we're gonna do x at -1, and this at 90. So that should be all sides of the rooms. And just to quickly point this out is that all of these planes are their normals are facing towards the center of the room where we're going to be putting the SteamVR controller, and that simplifies the rendering a little bit so that it's not everything's like front and back. And then, oh wait, I don't want the front, I want the floor. We're just going to duplicate that and make that the top. And for that, move this by 2, and then flip this 90 degrees. So there we go. So now if I move in the scene view, there we go. We got our room, all the cloth, and we can actually just go ahead and play around with the ball just to make sure everything interacts the way we want it to. So there we go. There we go. And the nice thing is all of the vertices are stay locked because we just duplicated everything. So yeah, we basically just kind of have our warping room. Not the same as BLARP, I will say that for sure, and I think BLARP's definitely looks better, but just to kind of get started playing around with things, like this is, I think, pretty cool. So with that, we now have a room, and I think the next step from here is to actually go ahead and import SteamVR and see what it looks like. You can get a sense of scale, because that's always super important in VR. And let me go ahead and open this, SteamVR plugin. Still waiting on Unity 5.4, because in that we will get native support for SteamVR, which I think will be super cool. Got that. Close this. Don't need the asset store anymore. Just go ahead, set all of the recommended settings. And cool. Close that. Save the scene real fast. Let's call this BLARP room. And yep, saving it just reloads the scene, which is what they recommend you to do once you change your lighting filter to linear, I think, instead of gamma. I could have those backwards, but that's one of the things that happens when you click through all of those buttons, is they do ask you to reset your room. So yeah, so now we have the cloth and our room set up. I think the next step is going to be, oh yeah, next step is definitely add the camera rig. Duh. So we just implemented SteamVR, and we can go ahead and put this, let me go ahead and reset what this is, so it lays on the floor. Make sure this is aligned with the floor. Yeah, there we go. We're just going to be using like the default scale, just fine. Go ahead and save that, and then let's try it out. And I'm sure my controllers fell asleep, but that's fine. Gotta save a little battery. And I think the scale looks right in here. Come on, controllers. It's like the one thing about this room setup is like when I get near, yep, there we go. So everything in here seems to be tracked accordingly. The ball we could probably make a little smaller. That's not too bad. And yeah, I think for the most part we're moving along quite nicely. And the scale and everything looks right. Cloth simulation looks right. So there we go. Sweet. So next step, there are a couple, yeah, I think the next step is probably doing the flinging motion. with the ball. How are we doing on time? Oh, it's only 10:30. Perfect. So let's go ahead and we're gonna get to a little scripting here. What happened to the clothing effect? It's still there. It only happens when I actually throw the ball into the actual mesh, which we're actually going to add the physics right now to actually do that. But we need to. It still exists. I'll just run this really quickly to show that off. There you go. Boom, boom, boom. So we just actually have to move our ball into this mesh. So let's go ahead, create a C# script, call it ball. Well, let's just call it ball. I was like, what would be a good follow-up to that word? And I was like, no, ball is fine. So with that, first thing I'm going to want to do is get a reference to our controller, because that flinging motion, I'm going to be assuming that you're right-handed. You can obviously, this is one of the things that you have to consider when you are developing for, why is it not catching the name? One of the things you have to consider when you're developing for the Vive, or I guess any controller setup in general, is that the Vive just kind of determines what left and right are, which may not be ideal for some users. So you either have to provide an option to switch that, or, I mean, honestly, I think the user can switch the controllers themselves, like if they really want to. So like, I mean, that choice is yours. I was recently playing out of ammo, and they provided a left and right hand switch option, which I think is nice to consider, but at the same time I was thinking, like, all it does is it just switches your left and right hand, which if I physically just switch them in my hand, I can do the same thing. I don't know. Something to consider. No clothing effect yet because you can't interact with ends. Yep, exactly. Oh, sweet. Happy to have you, Christian. And yeah, so I mean, obviously, if you just get here, you can definitely go ahead and I think you should be able to rewind a little bit if you want to catch up on anything. But otherwise, like, also just feel free to shoot questions. That's perfectly fine. Well, I think this stream we should have a lot of time for Q&A, so like that's awesome. And so yeah, so we're just gonna get a reference to our right controller. We're gonna be putting the script on the ball, and just to get started, all I'm gonna do here is first we're just gonna call, I don't like using var. I don't recommend using var, but if it's a must, it's a must. SteamVR. Okay, I can never remember this. So I can never. Unfortunately, the SteamVR documentation isn't up to par of what I would expect, but I do kind of remember where example code is. I highly recommend, if you want example code in general, go to the extras folder within SteamVR. That generally has some pretty good code that you can copy and paste, which I'm doing right here. So let's go ahead and copy that. And all we're doing here is we are getting a reference to the device, which basically, what is that? That is a SteamVR controller.device. We can go ahead and name that SteamVR controller. Okay, I can't type controller.device. Just so that we're good on the naming. And it's just another object, and it allows you to get access to methods like get touchdown. I'm just going to change this to get touch. And again, all that's doing is anytime we pull on this trigger, I can't even tell half the time if I'm in screen or not, but like, I think you get the idea. If I pull down, if at all I'm pulling down on this trigger any little bit, then it'll tell us. And let's just quickly test to make sure that's working with a simple dot here. So we'll be able to see that in the console. We'll go ahead and run. Oh, well, one thing I completely forgot is we can get rid of the main camera. So that main camera was there when we first created the scene. So that's, oh, I didn't even, okay. I also have to remember to put my ball, no, sorry. I need to put the ball script on the sphere. I'm just going to call this an orb instead of sphere. I don't know why. I just kind of like the names orb instead of sphere. And we're just going to drag a reference to the right controller here. And so let's see. So this is the left, is what it looks like. There we go. So I'm looking down here, but we can also pop open this console, and then we got a bunch of got here's. And anytime I'm holding this down, it's not just the first time, which is important here because we want to be applying a move, like give the orb some velocity or force towards us whenever we are touching on the controller. So that's super useful. And I'm going to show you guys a trick right now. And this is why I wish SteamVR was documented a bit more better. Let's call this trigger press equals, let's see if I can remember it. Get state dot r axis 1 dot x. Maybe. Let's see if I remember that. I think that's right. I'm gonna log that, and that, assuming I did that correctly, that should be the force of which, yep, okay, perfect. It's the force of which I am pulling on the trigger. So it's like, what is it right now? 0.2 press. If I press a little more, it's like 0.3, 0.4, 0.5, 0.6, and up to 1. So 1 is it's definitely pressed, and anything in between is anything in between. And the only reason I knew about this was because I actually took a look at BLARP's code on how exactly you find that, because otherwise I would have had no idea that that actually existed as a way to get that force. And you know, like, the interesting thing is, you know that that code exists somewhere, because like if you actually look at the, like, here, let me see. If I actually look at the model, like, you know, like you can see that they know exactly how much you've moved, because it's not just jumping back and forth between pressed and not pressed. It's, but it, I don't know. I could rant about that for days, but the point is, that is the line of code you need to get how much of a press was made. And so now that we have, okay, one thing I'm going to do here is we're going to get a reference to our rigid body. And a rigid body is basically what's going to allow us to apply force to the ball so that it moves towards us. And for that, I'm just going to write a quick private rigid body. It's pretty bad, not going to lie. And rigid body equals get component rigid body. So that's that rigid body, and obviously we have to make sure that, whoops, if I can ever type, that would be nice. Rigid body. I'm going to get rid of the gravity, and I think that should be good. Good for now, anyways. And so yeah, so that's rigid body. Do we need anything else? Oh, I guess I want to quickly add this type of, and like I was talking to, as far as documentation is concerned, like I know it sucks as like a dev, but at the same time, it's also, you have to give Valve, I guess, credit for the fact that it is some complex code that's going on. So I mean, I can kind of blame them. Like I can nag on them for like not having good documentation, but at the same time, like it's pretty amazing about that, the fact that like it kind of comes down to this one line of code as far as getting that data, because there's just so much going on with the lighthouse system and everything like that. So yeah, so we know the trigger press. We want to go ahead and get, for now, I'm just going to go ahead and call this direction. That's just going to be transform transform.position minus right controller dot transform.position. So that's just from wherever the ball is to the controller, that's just going to be our direction. And I might have that backwards, but that's just going to be the direction that we want our ball to move in. And then the only other thing we have to do is rigid body, and we'll be playing around with this a lot more, but I just kind of wanted to get the basics out first. Direction dot normalized dot our times, we can add in some scaling factor. For now, I'm just going to do 5F and trigger press. So we can have a bit more control on how we actually play BLARP. And we'll be taking a break in like 15 minutes, and then I'll actually go and play in BLARP for a little bit, just to kind of see if there's anything we want to actually play around with for the stream. But that's, and what we'll notice is, honestly, like when I play, I don't use the trick, like the control all that much, but you can. Let's go ahead and, okay, yeah, it's backwards. Of course it's backwards. How did I not? I should have just put it in backwards when I was like guessing that it was going to be backwards. And then it would have probably been the right way. Now it should, hopefully. Yep, there we go. So yeah, we get a nice little fling, and we get that clock simulation going on. And so, like, as far as the starting point is concerned, whoop, as you can see, definitely there's a lot going on with the clock, which I think is really cool. It's like, boom. I'm gonna pull that up somewhere. There we go. Yep. So like, it's kind of like having the force, which I think is really cool. But force, that's very hard to control, albeit all things considered. And obviously, I think right now, I mean, it's very hard to control, but you can. We'll probably at the end of the stream we'll play around with some of the numbers just to make it a little more fun, like BLARP. Like I think one of the neat things that BLARP does is, well, I'll put that code in a little bit, but one, they take into account the velocity of your controller, which I think is really cool. So like, if I pull like this, then all of a sudden like the ball will move with me. So like that's something interesting. But I mean, yeah, as far as like the basics of what BLARP is, we have the basics right now. A little jiggly wall and balls being controlled by the force. and what? 45 minutes? We have the basics? Sweet. So yeah, that's there's obviously a lot more to it. So for starters, one, we want the ball to be maintained within our room, and then the other thing is we want it to be a bit more responsive, and what we can also add in like targets, like I had in the start. Anyone has used Threshed any Fox VR toolkit? The teleport script doesn't work for me when I create a build. I actually haven't. I should check it out, but I think that you can. There's also a teleporter within SteamVR, although I think there is. Let me check if the bug is still there. Now I'm curious. Now that you mentioned the teleporter. Yep, bug is still there. From just since we brought up the topic of teleporter, you need to do that. You need the house ground target put in for if you want to use a collider. Silly bug, but that's that. So yeah, let's go ahead. Oh yeah, I also don't use the shield at all in BLARP. Maybe I should, but if there's time to show and explain the devs code, yeah, we can definitely jump into that at the end of the stream. I think there's definitely a lot going on there. We're gonna cover the majority of it, but just it was written a little bit differently from the way I'm gonna implement it, but that's fine. Like, there's obviously more than one way to actually implement anything, right? Well, that's not true, but Okay, so let's go ahead and add not a mesh collider, box collider. So the box collider is what's going to basically allow us to stop the ball from going off into outer space where we never see it again. And let's go ahead and look at the box collider. Yeah, okay. I'm going to go ahead and look at the box collider from this perspective. Actually, that doesn't look that bad. But yeah, these are all of the box colliders that I've selected. I'm just going to go ahead and select the floor so that we know which box collider that we're dealing with. Test perf. That's the bug yesterday. Cool. Awesome. This is the type of conversation I also want to see in the chat, is people talking about their own projects and other issues that they've run into. That's, I think, super cool. So for the floor, I'm going to go ahead and shrink this down a lot now that I actually can see it. Like, half the battle sometimes with these box colliders is you got to see where exactly the mesh is in reference to what you want. So maybe a 2 by 2 by 2, and then we can go ahead and I think this is in the Y. Let's move. Nope, not in the Y. In the X. Nope. Okay, in the Z. Move this down by like -1. So -1, and the reason I'm putting it, I guess I should mention this now. So what I'm doing right now is I'm adding a collider behind the wall. I'm actually going to push it down a little more, but the reason for that is we want it to be intersecting with the wall. And unfortunately, one of the things that, and I mean this happened also in the BLARP code as well, is when you put a collider in, it's not going to be on the warps of the mesh. So like we won't be able to get it exactly, like if the cloth has moved X distance closer to us, we're not going to be able to like have it bounce off directly on that. We're going to have to take a little shortcut for performance as well as like just practicality of having the collider basically just going to be like a wall. And so like for that, I'm just going to move it a little bit behind there to just kind of give me some leeway as far as where the ball can actually go. And also I'm making it a little bigger than what we need it to be. It doesn't have to be this big. I think I will actually shrink it to be 2 by 2 by 1 and move this to like -0.5, -7.5. Just give me a little leeway there. This looks right. I think I'll make the X and Y like 2.5 by 2.5 just so we get some overlap with the other colliders. We can go ahead and copy that, copy component. Go select all of these and then paste component. Oh, whoops. Oh, that's fine. We'll get rid of that one. And so yeah, so now we get this nice looking grid, and that basically ensures that we kind of make sure the ball stays within our space. So that's pretty much it. We doesn't look like we have any we have a lot of overlap, which is good, so that the ball doesn't go breaking through the collider. Because if you somehow once we tweak the settings a little bit, you can probably get the ball moving a lot faster, and in that case, it ends up kind of, there's a possibility that if it moves fast enough, then between frames, it's not going to actually bounce off the wall. It's going to actually go through the wall. And you can kind of change that a little bit if you add a rigid body to the walls, so that or actually, sorry, not rigid body to the walls, if you make this collision a bit more continuous as opposed to discrete. But for now, like, we're not going to be moving the ball terribly fast. So that's fine. And let me grab a controller. Let's say one of the nice things. So now it bounces, or it doesn't really bounce, and that's probably the next thing we're gonna do before the break. But like, yeah, so like it's definitely moving around, and it's stuck. It's not gonna fly off into space, and then we're never gonna see it again. that's definitely one thing that's nice. So yeah, so that's putting the colliders in there. And then the other thing I want to bring up, and we're just going to do that really quickly right now because it doesn't take too long, is what we're going to do is create a physics material. I'm just going to call this bouncy wall. And let's get rid of friction, maximize bounciness, just like a bounce house. And so basically, physics material is exactly what it sounds like. It's a material that you use for physics. So you can control friction and basically any interactions that the physics engine needs to control as far as like bounciness and friction is concerned. So you get these few properties and you apply them to a collider. So in this case, there's the physics material. So we're just gonna do that on all of our rooms. And go. So now yep, there you go. So yeah, like it bounces a lot more. This is obviously, I think, a little too bouncy, so we can drop the bounciness factor. Like that's not an issue, but basically it's not losing momentum as far as bounce is concerned. So yeah, that big difference as far as like what exactly happens. So I guess it's just gonna keep going back and forth for days. So we can obviously drop that down, but I think you guys get the general idea of it. So yeah, so now we have physics material, colliding, ball bouncing. The next steps probably are, when we'll do this after the break, is we're going to go ahead and maybe shrink the ball size a little bit because it's a little too big. I'm going to add a line render in, and then we'll change the actual code for to incorporate velocity and some of the other physics properties that are involved with what BLARP did. And then yeah, we'll see how far we get with that. That should, I mean, I think we can get through that pretty quickly after the break, and then hopefully have some time to actually look into BLARP's code, because I think someone asked for it, so we'll definitely try to get to that. So, but yeah, give you guys some time to catch up, get a coffee, get whatever you feel like. I'm gonna be playing BLARP for like 5 minutes while we take that break. And I want my headphones. It's definitely like, depending on like how immersed you can get into VR experiences, I think BLARP is one of those things where it can get pretty trippy. And I'm curious if anyone has tried BLARP on like if they're drunk or high, because I feel like that with the colors and everything, that could be a pretty trippy experience. All right, so let's go ahead. Come on, control. There we go. So he has a shield in here, and just like someone mentioned in the comments, like I have no idea how to actually use this shield properly. I mean, as you can see, so they list your high score. Should I get my camera? Yeah. Okay. So they list your high score on these balls, so you can clearly tell I haven't played all that much with 15, but we have a shield, and everything here is definitely a lot more responsive than what we have. We have a line render here that we will again, this will be something we implement, not as pretty as what he has, but definitely something to play with. And like I said, let me check that. Yeah, okay, you can definitely see what I'm saying. Yeah, I definitely think he did a lot better of a job with the wall physics, because they look really nice. But I mean, when we get to looking at his code, we'll kind of see that what he did was a bit more complicated than what we want. And there I go again, kind of telling myself. So like, if the BLARP ever touches my controller, then I die. This is just the gist of it. Which, as a game design mechanic, I'm not sure how well that works, but I think a snake approach would have been a lot better. Where's the other one? Here we go. But I think flinging is definitely a really nice effect. And like I said at the beginning of the stream, it's like one of those things that like you absolutely do need VR for, because otherwise you don't get that sense of depth. Whoops. Whoops. Wait, where's the start? I actually haven't set up room scale, so I can definitely imagine that I'm about to like hit a desk or something else in this space. Oh, and I think the other thing I'll point out is this line. I call it a line renderer. It's a trail renderer in Unity. And again, I hit. What did I hit? Oh, I'm hitting a desk back here. Got it. What's theirs? So, but yeah, it's called a trail renderer, and that's how he's getting that nice effect of a rainbow following the BLARP based on its velocity. So I think that's just something to point out. I think I'll point it out when I get into his code, but probably not gonna have time to implement it. Also like the sound effects. Those were nicely done. I'm also not terribly sure like what the point of this psychedelic void looking goo blob, if that's what we want to call it, is. There you go, I killed myself again. I feel like if you like are really trying for a high score, you could definitely get one in this game and like go for a really long time. But I'm clearly not trying for a high score right now, especially with me running into half of the stuff in this room. I'll try for a high score and out of ammo any day, but this is just like something like I go and mess up all of the time. Alright, there we go. Although I have to say, I really do like that it's not pressing a button to get into game. It's like it's actually playing the game a little bit to get into the game, which I think is just like a really cool effect. Come on. There we go. Alright, let's see if I can. Woo! Probably by the end of the session, I'm gonna like realize that I've broken like half this room. Okay, this is gonna be. I'm gonna shoot for 10. That's what's gonna happen right now, because I do also want to show you guys. Come on. Okay, it's 2. All right, I'm gonna shoot for 10. Hello. Yeah, sure. Let's see.
Thank you.
Yeah. I didn't see that coming. Alright. How are we doing on time? Alright, I'm gonna play one more. And then we'll get back into the implementation, because you can clearly tell I'm struggle busting hard. Where is it? 2. Here. I'm gonna get 2 before I break everything in this room. Four. Where's the where in the world? But like everything here is really smooth, which I think is really cool. That's 5. Oh, and I guess another thing again, this is probably not something we'll implement because I just noticed it, but like the room does grow as the room does grow as you play further and further along in the game, which I mean it's required because you're adding more. Maybe what are they called? Like in his code, he calls them babies, which I think is maybe not the best name for those psychedelic blobs, but still, I think I like calling them blarps. even though that's probably not their desired name. Oh yeah, the Vive controllers are super strong, super sturdy. Well, I say that now until I break them, right? Can you move your video screen? Oh, whoops. Let's see. Can you move your video screen to the bottom left side or middle so we can see what you're. Oh, okay, that I can do. That is an easy fix. Let's see. Wait, where would be better? Oh, okay, I see. I sometimes forget that the components actually get buried there. So let me go ahead. Let's move it here for now. I'll probably move it back later, but just so that you guys can actually see with the box colliders, just kind of some of the settings that I had. So those are the box collider settings. I'm using -0.75, 2.5, 2.5, 1 for all of them. Let me go ahead and open that. Reaper's Whisker Box is one of my favorite demos available on the site. I need to honestly like look through all of the stuff that he has because I think he's doing some really cool work, and it's just super awesome. It's super awesome to just kind of see some like smaller. I don't know if he's working with others or like by himself. Kudos if he's working by himself because like it's definitely like sure like it kind of feels like a demo, but there was I think a lot of thought that went behind it, which I think is really respectable. So yeah, let me go ahead. Let's jump right into this. And first thing I'm going to do is actually drop the size of this thing down by 0.7. The base stations are not strong. that I'm like those I am scared to drop, and I've seen some bad things happen to them. that yeah, not good things either. So for the rigid body here on the orb, this affects like when we apply an add force to it. We're going to go ahead and drop the mass down because, as you know, force equals mass times acceleration. So the more mass we have, the less acceleration the BLARP or thing, whatever, is gonna get. So we're just gonna drop the mass that we get a bit more acceleration on there. I've dropped one, and I'm not sure. I'm not sure. I enjoyed having the lighthouse drop. It did work, but like something felt a little off afterwards. Yeah, you're right. The one complaint I have about the lighthouses though is that you have to unplug them. I wish there was an on and off button. That is my big complaint about the lighthouses. So yeah. Well, this has nothing to do with lighthouses, but we're gonna first add a line render to this thing. We want 2 positions. I'm just gonna leave up here, and the line render is just like we saw in BLARP. You're gonna have the dot. You have that dot 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 between where your controller was and where the BLARP was. And so we want to basically have a line between where this guy is and where our virtual BLARPs, all of them are. So we're going to do that with a line renderer. And just to quickly get something set up, and then we'll play with the parameters around a little bit, so first we just want a line renderer in here. Let's call this line. We'll call line equals get component line render. So that's just getting a reference to our line, and then all we're going to say is set position, and this just tells us the position of wherever we, or sorry, the index of which point we want to change in world space. So our first position is going to be where we actually are, so that's transformed opposition. And then, of course, the second position is where the controller is. So it's just going to be right controller dot transform dot position. And so we set that, and then we're updating them every time because obviously both of those things are moving all the time. And luckily that stuff is in world space, and we have references to those on our script, so we can go ahead and change that easily. Can you only have to turn off the B and C will shut down? You only have to turn off the B, basically, and C will shut down with the lack of sync. Huh. Oh, there's a Bluetooth? Okay, I didn't know that there was a Bluetooth. But when you turn off B, it's still, for whatever reason, it's still, I mean, C is still on. It's like using power, and it still gets hot. And so yeah, so this is a line renderer. As you can see, we get this nice magenta, pink-looking thing, and by nice I mean ugly as hell. But like it moves based on wherever our controller is. Swing it around. Actually, you can see that it's a lot more responsive right now because we dropped the mask down a little bit, which is good. And so I'm just gonna, let's quickly change the properties on this thing because that's the reason why, well, one of many reasons why it looks ugly. So for that, I'm just gonna drop this down to like 0.05, 0.05, and that's just gonna be our parameter settings for start and end with. And so that makes it a nice small thing. And not 0, 0.05. I mean, I guess we could make it 0. And 0.05, 0.05, so that's start, end with. Yeah, it's I end up turning off both. Like, I don't know. I just kind of wish there was like a flat turn off button. I think that would have been nice. I'm surprised they didn't think of that. And we're actually going to go ahead and make, just like I had in the start, we can go ahead and add a material for the line renderer as well as the ball. Or material, go ahead and call that and make that orange. And then just go ahead and apply that to the orb as well as the line renderer. So just drop that there. And I mean, like, it's just any material. So like this one, it's using the directional light for reference, but like if you wanted to ignore light, you could do that. You can do really whatever you want. I'm just doing orange for simplicity, and like it works. That's all I can say to that. So yep, so we have the orb material, we have the blue walls, we have our line renderer. Let's go ahead and I'm just gonna pull up. This is, oh, so okay, I forgot to mention this. And so one thing that is done in BLARP, it's a subtle effect, but I think it's an important effect, is he uses a spring joint. And that's what that's going to do is basically just kind of like what it implies is make the, well, let me first add this. So I'm going to add a rigid body here. Don't use gravity, set this to 0. And so it's basically, think of it like kind of like having a spring between our right controller and the ball here, and it's just kind of it adds a little effect as far as like movements are concerned and kind of helping with the pull effects and stuff like that. So I think it's a small detail, but I think a pretty important one as far as like just making things flow a bit more naturally as far as physics is concerned. Obviously, like this are all stuff like you can play around with, but it's just like getting that physics right to make the BLARP feel like it's supposed to. I think it's just pretty cool. So with that out of the way, we're gonna go ahead and so I'm gonna remember like all of these settings we don't really need. I'm gonna set everything to 0. We just keep the tolerance the same, and then we're gonna go ahead and drag our right controller rigid body onto that spring joint. And so it's important that you make it is kinematic. That basically means you don't want to apply the physics forces to it. And as opposed to like me writing out all this code, I'm just gonna go ahead and show it to you guys. So I have it off screen here, but this is the basic code that we'll need. Yeah, okay, all of this. So all of this here, and I'll walk you all through it, assuming it will copy and paste, which it won't. Of course it won't. Sometimes, yeah, I honestly should really switch to Visual Studios. Like, there are some issues with monodevelop. It's kind of sad. I just use it because I've always used it, which is probably not a good reason at all to be using it in the first place. So most of this code was actually copied straight out of the BLARP code, and just to like walk you through what's going on. So the first thing is what we did exactly, which is, actually, hold on, let me pop them in the chat real fast. So the first thing we did is exactly what we did, transform.position minus right controller.transform.position, just getting the vector between which we are, the direction we want to throw. And we save its magnitude and then normalize it. So that's important for us. And then the next thing we do is we take a look at the velocity of which I'm throwing this thing. So if I throw it up like this, so let's see what it was. So if we imagine this controller here is the ball and this is the controller. So if I, that might be better. So if I want to, so this is our transform, is the direction of which we are going to be pulling the ball. But I might actually end up throwing, moving my controller up like this, which is a different direction. So we want to take that. In this case, the code only takes the magnitude of that throw into account, but you could also take the direction as something that you want to consider. So, but yeah, so that's basically something that we have to look into. And then we also take the dot product just to get the, I'm not entirely sure why the dot product was taken here. I mean, it's another thing that you can take into account as far as like the proportionality for, like, say, the projection onto the direction you're throwing. Again, just something to think about, but like not something necessarily you have to do. And these are all things I think you can play around with. You have the trigger value, which we did, and then you just go ahead and everything is in the direction of where we want to throw, and then we just tack on a bunch of parameters to get the field right. Wonder if that copy paste glitch will ever be fixed. Yeah, I don't know if it ever will be. I don't even know what causes that glitch in the first place. It's pretty sad, in my opinion. So yeah, so this is just to get the magnitude right, and then we just add that force just like we did before. We set our spring joint accordingly, and I have this one, I think he had a 0.5 before. I don't remember what it was, but like that's just to play around with the effect of that spring. I did my own add force up here, but he, oh, sorry, this was commented out from him, if I remember correctly. So like, I think he had the add force there before, but then I got rid of it. And the last thing we do is, since we're toggling around with the spring joint, we just set it back to 0 if we're not actually pressing the controller. And then we still have the line renderer stuff. So that's just kind of what the logic that he used for the BLARP game that you just saw actually is this is the specific code that's going on. He's basically looks at the direction of where your controller is and where the ball is, takes your velocity into account, takes the dot product into account for getting a little projection math going into there, multiplies everything together, and then boom, that's what you get. So there's that, and we can just play around with that actually. Oops. I'm gonna get rid of my headset, or not headset, headphones. Put them down. Put this on. Turn the ball. This thing on. There we go. So, yep, everything's a lot more bouncy. For the physics material, I'm gonna go ahead and make that smaller. I think I'll actually make the ball smaller. It looks a little too big, and everything is very bouncy right now. Pull that in, pull that over, boing, boing. But yeah, I mean, it definitely feels a lot better and a lot more responsive, which is something, again, to play around with, but still valuable for sure. And where am I? I want, oh, physics material. That's what I want. Drop this down to like, I don't know, 0.8. I think that'd probably be good. And just so it's like not bouncing all over the place. So yeah, so that's making the velocity feel a bit more natural. Again, I think this is also stuff to play around with, especially it's one is the code side of things and the force that you apply. The other is obviously the settings that you put on the rigid body, as for specifically like the mass and your drag and angular drag and all of that good stuff, because that will also affect how exactly the force is applied, because it's all force equals mass times acceleration, basic physics from the good old high school days or college days, wherever you took it. Wherever you took physics, if you took physics, that's where you would have learned it. So yeah, so that's that part, and then we can add some basic game mechanics to this, just to finish this up. Like that is actually honestly probably the easiest part of this whole process, is adding the basics of an enemy that, like, when you hit it, it spawns another enemy, just like in BLARP. So for that, the other thing I'll just quickly do is make this 0.5, 0.5, 0.5, because the ball still felt a little big. And for this, we're going to go ahead and add a cube somewhere. I'm going to go ahead and put that here. And I'm going to make it red, because I can. Let's call this enemy map. Make this red. Apply that here. And I don't want the cube nested. And let's just create a quick script. Actually, no. Let's first create a folder for prefabs. Go in here, drag that in, drag this in, so we have prefabs for that. Good. Undo that. Get rid of plane, because that was old. And direction light or broom. Yeah, so I think we're all set with that. We can go ahead now and create a C# script. Let's call this enemy. And we will go ahead and open that up. And there's actually not that much code in here. All we're going to really do is void on trigger enter. I'm not going to do any checks right now, but like, you obviously will probably want to, especially if you add more complicated things to the game. Well, first we want a reference to actually, let's call this ball prefab. So this is the thing that we're going to be spawning, and so when we do an on trigger enter, basically whenever any ball, or actually anything hits this script, or specifically this script's collider, what we're going to want to do is go to instantiate ball prefab dot game object, and then specifically at this position and with 0 rotation on it. And so that basically just says, let's put a ball right where we were. And so that creates the ball. The next thing we're going to do is instantiate. Actually, no, I'm going to create a method for this. Just create random cube. And then we're going to destroy this .game object. So obviously the destroy is basically get rid of our target. And let's create our method, create random cube. Random cube. And so create random cube, what we're going to do is basically just create a reference to the position we want. And that's just going to be a new vector 3. It's going to be at, so if we take a look at here, this is positioned specifically at, where is it? 5, 5, 5. So this is at 5, 5, 5 by 5. So in the x direction, x and y direction, we want, no, not x and y. X and z direction, we want a random value between like -4 and 4. And in the y direction, we want it between like, sorry, not -4 and 4, -2.2 and 2, I think should be good. And that'll spawn it somewhere in the middle here, and then 0 and, actually wait, let me, instead of trying to rationalize all these numbers, let me just go ahead and see if I can, let's see where things spawn and then do that accordingly. That's probably the better way of testing. -4 and 4. This is going to be, this is 0, 0, and 0, and did I put it at 2? Yeah, 2. And it's 2 and 9, or sorry, 1 and 9, and then -4 and 4. Oh. Yeah, for sure. Thanks for sticking around, Mickey. And so yeah, -4, 1, 9, -1, 4. So let's see. Oh wait, I didn't even put this on. So now we've created a random cube. I actually have to finish the code. This is going to be this .game object. So we're just going to make a clone of the enemy. We're going to put it at the position, and then again, no rotations. So we're just going to put quaternion.identity here, and that'll create it. So we create another ball at the same position of where our current enemy is. We're going to create a random cube in our space, and then we're just going to go ahead and destroy this target. So let's try that out. Oh wait, did not put this on the enemy. And so we're going to have to drag that here, drag our prefab, which is the orb, onto there, save that, apply this, and let's test. Testing's the fun part. Like that's one thing I like about VR, is like the testing component of it. Let's go ahead and move you here, move you back. Nope. Come on. Come on. If I was good at BLARP. Oh, okay, I have to stand up. Oh, come on, hit it. Oh, right. Okay, so the reason that happened was because I forgot to click is trigger. So is trigger basically makes it so that, unlike the walls where it just kind of bounces off, is trigger will detect that I actually entered it. Come on. Go, and yeah, so now we have a, whoa. I might have to control the clock a little bit, but yeah, we definitely now have the orb. And now the reason that that ball there, well, one, it doesn't even have a line render. Two, it, let me sit down again. So one, it didn't have a line, or two, it wasn't responding to us, and that was actually because, go to the ball script, I actually had set the right controller as a reference here, and so that doesn't get set on the prefab. So we scroll, where's ball? So we scroll here, because a prefab is not in the scene, it's not, we can't really put a reference to it. And so to fix that, I'm actually going to create another very tiny script. I'm just going to call this controller manager. See ya, thanks for stopping by. And let's go ahead, controller manager. Let's just create quickly a controller manager instance. So this is just singleton behavior. We can create now here, oops, SteamVR, and SteamVR, tracked object, controller, let's call it right controller. And I think that was, yeah, that's all we need here, actually. Oh wait, no. No. I forgot, we have to set the instance. So on awake, what we're going to do is if instance equals null, instance equals this, and then void on destroy, This is just the cleanup. If instance equals this, instance equals null. So yeah. So now let's just quickly add that to the scene, because as with all managers, they need to be added to the scene to be ordered to activate. And we can go ahead and drag that in here. And now in our ball script, we can now actually go ahead and make this private. And then in start, what we're going to do is write controller equals controller manager dot instance, because it's static, and then we just get write controller. So now we just have a reference to that. And that's probably the easiest way to get access to something that we don't really have control over. So now that that's out of the way, if we go to our prefab here, where's ball? So yeah, so now that that property of setting the Steam controller is now gone. So we can now go back to Unity, and let's just go ahead and test it and see to make sure I didn't mess anything else up. Oops, come on. So there we go. So now I have both of those guys. Actually, let's get a little more control over them. They can, even 0.5 seems big now that I look at it. But, oops. Yeah, definitely need to control the clock a little more, that's for sure. But like they do interact with each other, and like all the physics is applied to them. We can go ahead and pull you back, get a third one, drag that here. Oops, where did that cube go? Oh, cube is above me. Yeah, I think the scale is a little off. Things seem a little big. So we can change that, but I think probably what might be a little more valuable for people is if I go ahead and actually look at the BLARP code. Come on. But yeah, that's the basics of just kind of like how that was set up. And obviously you can add end states, and you can add a bunch of different things. If we want like a poison target, like you can add that. You can pretty much add whatever you want. But like as you can see, there wasn't, as far as like the basics of it, like this is just code that like, needs to be played around with to make things feel the way you want, as far as like the kind of the flow of like pulling stuff and applying force and making sure the force feels responsive. So like that's there, and that's again, that's an aesthetic thing that you need to play with. As far as the enemy was concerned, like nothing here that was too fancy. It's just making copies of ourselves and positioning them in the world according to our scale. So like these numbers would kind of have to change based on the size of our room. I think 5 is probably a little too big. We might want to bring that down, but that's pretty easy to do actually. I mean, since we've grouped everything, it's just bring 5 down here. Controller manager, that didn't do anything, and those were really the only scripts we needed. Most of the work was actually pretty much done in the editor to make sure like we added the spring joint, we added the line render, we added the camera rig, we added, what else did I add? The orbs, rigid bodies, all of that good stuff. And I think that just kind of goes to show like how responsive Unity is as like a tool, like to like really get you started even if you have very little coding experience. And I think that's pretty awesome. So without that out of the way, I'm just gonna go ahead and save that. And so it's like 11:30. So like the rest of this pretty much Q&A, like ask pretty much whatever you want, whether that be specific to Unity, whether that be your own project, whether that be BLARP, BLARP in general. But yeah, again, not not that much work involved, which I think is really cool, to just get something working and then add the aesthetics however much you want after that. But I have the ball game here. I'm gonna go ahead and again show you where you can find that. So if you want, again, if you want a reference to Kabibio's ball game, the BLARP source code, like that's all available. But please, like, if you're taking a look at this, like, please support the dev by actually purchasing it on Steam. It's again $3, just a cup of coffee. That's all it is. And yeah, so just to show you all. So it also does look. I mean, SteamVR has been updated since he's made the game, and I think when was the? Let me see. When was the last update? I don't think he's touched this in a while. March 27th, probably. Yeah. Wait, is that right? No, that was contributors. Commit. When was the latest commit? Latest commit was March 27th. So definitely has been a while since it was updated, but that's fine. Let's switch that to 2D mode so you guys can actually see what's going on. I don't know why it was set to 2D mode in the first place, but that's that. And so yeah, I think it's just one scene. I'm gonna go ahead and run it just so you guys can actually see that this is BLARP in all its glory. What's interesting actually is, so I've been playing around with it a little bit within the editor, and then I purchased it on Steam, and for some reason, my high scores actually transferred over to my Steam account. So I'm not really sure why. I mean, that definitely shows that, and I hadn't looked at this code explicitly to like know what exactly was getting stored where, but it looks like it's getting stored some global space because that's at least for high scores. Maybe we'll take a look at the code for that. But that's just like an interesting choice. It's not being stored locally. I mean, that's probably what I would have done. But definitely, I guess, nice to have your high score move with you wherever you go, right? But yeah, I mean, it's exactly the same game. Nothing really new has changed. We have our shield. We have this. We have. You can touch that, which I think is cool. But yeah, exactly the same. And go ahead, close that out. And so yeah, let me know explicitly what you want to go over actually with this. If who asked the question? Scroll through this. Hey, if you like, let me know if you're still around. Let me know exactly what you would want to see. I mean, I can obviously just kind of go through the basics of like what I saw when I was going through this. So like, obviously, there's the camera rig. He has the core of the game is like done through his ball game script, and there are like, actually when you play the game, I think he adds a ton of audio sources on here, and those are all, like how he controls each and everything. I don't think he edits them specifically. Close that. And so yeah, I mean, there's a bunch of audio clips. There's a bunch of the prefabs are all on here. Like most of the game logic is controlled there. Let's see. He doesn't. He has a little. In case this is. I was wondering how you go about doing something like painting or drawing on the surface. Yeah, I've not looked into that too briefly. I mean, like, I'm happy to answer that unless people want me to just go on the BLARP side of stuff. There was something. What was it called? It's not a render texture. It is. I think you can just do it actually with a normal texture. Well, Unity Paint. I mean, obviously there's this, but I think with. Oh wait, oh no, this is free. So like you can actually take a look. Let's actually go ahead and take a look at it because I think probably has some valuable tidbits as far as that's concerned. I'm gonna go ahead and actually let me download it in a new project. Let's go ahead and go back to my test. No, go back to the test project. I just have like a random project that I do like all of my test work in, and it's just convenient for me. It's like I don't really want to have this code within this specific project, but I can do it in something else. So that's what that is for. We can go ahead and launch that. Get the asset store within Unity. Grab some water while this download. Oh, I haven't downloaded this before. I thought this was paid for, but I guess we can take a look at like how this is actually done, and then I think most of the things would transfer over. Yeah, they're using a texture painter. Grab some water. And yeah, that should be imported. We have SteamVR in here. Just go ahead. I want to see how to compare with your code. Yeah, for sure. I had that opened up. I'll go back to that after I just kind of walk through this texture painter. So I guess everything's in resources here, which is weird. Go, yeah, sure. And pull that open a bit more. I don't need that. I just want to make sure I understand. Yeah, okay. So yeah, so you have a GUI here. You can change the paint. Obviously, if you're doing something along the lines of like I believe it was the graffiti maker or something like that. We can definitely do that. But I think the way this works is he just creates his own texture. That's what that is. He creates his own render texture. It's like he specifically uses a render texture, and then it's just figuring out where on the mesh you're hitting. So if we look at the script, I think this one. He figures out where on he does a ray cast to figure out where on the texture you've hit, and then just applies the color to the render texture, and then saves that. I think is basically all that's happening there. And I feel like if I remember correctly, like yeah, you could probably honestly just copy this code for the most part, and it should work. Like, and then just obviously apply your own. And oh yeah, no, yeah, I think you have to change your own interactions. Where is it? Yeah, this is. Yeah, he figures out your UV coordinates, and then based on that, he'll go ahead and update the mesh accordingly. So that. Let me know if there's anything specific you want to see, but that's just kind of the basics of like what's happening as far as painting or drawing on a surface. I'll go close that, and yeah, glad that was helpful. And yeah, I mean, definitely like ask me like anything about that. Like, I'll say like we can try and figure that out together. Because I mean, I haven't specifically used that, but like I'm sure that's a good place to start. At least that's what I remember when I was like looking into my own project as far as that was concerned. Um, but yeah, I guess going back to this, since we kind of wanted to see what the differences were, and there aren't too many differences. One of the things he does different than mine is where is it? So the way I set it up is what you have the balls are kind of controlling the logic as far as how they move, whereas for him, where is it? Where is it? Fix, yeah, update baby forces. Yeah, he calls them babies, which I'm like, I don't know why, but like sure. He basically with the ball game script, he has references to all of the babies he's created, and he just kind of goes through and updates them within his own for loop, as opposed to the way I did it, which is I put a script specific to each baby, and then go ahead and actually update it per component. So that's just a small difference. Like it's not a huge difference. Um, there, there are advantages and disadvantages to both. I think performance-wise they should be the same. I think. Actually, I don't know. That might not be true. The for loop might be a little more performant, or maybe not. I don't know. I don't know how Unity actually goes about doing the parallelization of its components. Actually, I don't think it parallelizes them. It does it synchronously. Yeah, I don't know. I should stop talking about that because it's like that there are a lot of parts of Unity that are a little confusing. Um, but I mean, as far as like controller stuff, he does have a nice controller info script in here, which you can check out. Basically allows you to it's a singleton, I guess it's like a singleton version of a way to store all of the data that you need for the Steam controller stuff. So for example, like your velocity is stored here, your angular velocity, your thumb position on the trackpad, all of that stuff is he decides to put them here, and then it's based on whatever controller you want, and then you can get that information publicly, basically, provided you have a reference to this thing. So just kind of simplifying that out, which I think is nice. So that's the controller info. What else is in here? Game, hand script. I don't know what a mama is. Oh, yeah, I don't know. Some of the naming in here is weird. Here's the shield, which I think is just, yeah, it's not doing anything. It's just kind of controlling its its size based on when you pull the trigger. That's simple. The room audio, that's all there. And then I mean, the biggest difference is obviously the bouncing in the room, which is, oh yeah, and here's the room. You can see exactly, basically like looks exactly like what we had before. I think his colliders are probably a little different. I mean, yeah, he's using 111 and has it scaled by, oh, he is using 5x5, but he has that scaled according to the room, which we literally did. I had no idea he actually used 5x5, but now we know. And although I think his 5x, his 5x5, you're not at the bottom of that 5x5. So it's actually 2.5 meters above you and then 2.5 meters below you is what he does there. And yeah, I mean, I think other than that, like nothing terribly crazy. Let me know if there's anything else you want me to point out. But yeah, that's that's just kind of how I look at things. As far as the room is concerned, there's his shader, compute shader. So he has this here. It's already compiled, so I don't believe that source code is available. So that's obviously something that would need to be looked into as far as like how you develop that by yourself. And I'm not, to be honest, I'm not terribly sure because I haven't spent too much time looking at compute shaders. If we like, yeah, I think Unity does have a page on that. Compute shader. And I think, yeah, so compute shaders are specific to DirectX 11, and they're only gonna work with or OpenGL. So you can get it for Windows or Android, which are probably the two biggest VR systems out there. And but yeah, I guess if you wanted to port this to iOS, that could be a little tricky. Or I mean, like the cloth stuff works fine, but like something like this might be a little tricky to do. Yeah, I mean, like as far as like how different it is from other shaders. Yeah. Yeah, I mean, it works really well, and again, like that's just something to play around with as far as getting the effect we want, but I think the cloth one works just as well, which is interesting. So yeah, there's that. And yeah, I mean, I'm just gonna chill here for the next 10 minutes, pretty much. Or actually, I might end this early if like there's nothing else. I'll just, yeah. I mean, if you want to talk about anything else, I'm down to do that. Or I don't know. I'll leave that up to you guys. Oh, I guess the other thing he does, like for the rendering, is he has a post-render effect somewhere. I don't remember where I saw it. I saw it for like a second and now I lost it. Oh yeah. Which I forget what this does. What does post-render do? Yeah, this is basically what my process was when I was going about looking through this code. I was like, huh, what does this do? What does this do? What does this do? And then Google is your friend. Google is such your friend. This render is called, okay, there you go. After camera has finished rendering the scene, so then you can apply any After Effects to it, really. I guess is the way to look at that. Sweet. Oh, he's just calling post from here. Okay. I score ball. Actually, doesn't even list here how he get. Where did he get the number? What do you think of the Lenovo Tango? Oh yeah, that's been. Was that announced this week? I thought that I've seen that around for quite a while. Or maybe it's a different phone. I think it's the one that has Tango in it. Was it Daydream? Is that one Daydream ready? Daydream ready. Lenovo Daydream. We do some more work with Tango as it launches to consumers. I need to get the devices. I do have a Tango tablet, but I don't like developing with Tango primarily because of the fact. I don't know, where is it? Lenovo Tango phone. I don't like developing with it because it doesn't have a good battery life and tends to overheat really fast. But I mean, if people want to see Tango, I'm down to do that. And as far as like Daydream is concerned, I I have mixed feelings about that. I mean, if you've seen my my little rant on like the Daydream stuff, like I figured out, I'm pretty confident right now that it doesn't card. So the SDK for Google VR does not support. It doesn't support the controller for cardboard. It only supports the controller for the Nexus 6, which is the Daydream Ready equivalent. It's on June 9th is the announcement. I'm gonna have a look at made for a customer pitch this week. Yeah, I mean, VR Worlds. I mean, if it's somewhere I can look at, I'm down to look at it. So on June 9th is the announcement. Wait, is it this thing that I'm pulling up right now? Oh, oh, as for future team, can you make one on making hollow ball and maybe explain the lab render? Oh, lab. I haven't even looked at the lab render, but that could be something cool to look at. Yeah, I just need to spend some time looking at it. But yeah, I think lab render would be cool. I haven't played hollow ball. I should play hollow ball and see how that works. But yeah, I'll play around with hollow ball and then we can. I'll see if that makes sense to do a stream on if I can like break apart things. It's just kind of like when I'm looking at these games, it's definitely like it's like looking at how to like simplify some of the complex stuff that they do and like make that in a digestible form. But yeah, those are definitely good suggestions that I'll take a look at. And send the link. Yeah, I don't know. Maybe tweet it to me. I can take a look at it. Yeah. So this thing. I mean, I think it's Project Tango is amazing. Like I think having played around with it, and it's like it's one of those demos that I give to people. I have on my GitHub page. I have it's like a really simple like with Navi. It's like using the positional movement to like you can walk around and take pictures with Navi, which I think is really cool. And people love that demo just because they feel like they can walk infinitely, which I think is fun. And as far as like how what I guess do we know the price on this thing? Apps. Like I think there aren't that many Project Tango developers though. That's one thing. Tiltbrush. You mean an extension of what I did with Tiltbrush, or anything like specific as far as like for Tiltbrush? But yeah, I think there are some cool applications. It's just it needs more developers, which I guess we'll find. It's just hard to develop for Tango because there aren't that many. There aren't any phones. There aren't any consumer-ready phones out there. It's just the tricky part. But like, it's definitely a good, cool community. And yeah, for Tiltbrush, let me know anything specifically you'd want to see. View shader and close that. Oh yeah, this is all the cloth stuff. I had this open, but didn't actually end up talking about it. But like, yeah, this is where you go for a bunch of properties. It's 500. Damn, Tango is so fun. Like, wait, where's? I think I have Rabbit Hole VR. Did I? Yeah, you can see someone using Tango here. That was my Tango. Oh yeah, well, it was from minus the fact that I had that code piece that I pulled in and just kind of talked about, because otherwise that was the other tilt brush is like one of those things that I thought would be pretty easy, and then I realized like to get the effect the way you need it to be, it actually does take a good amount of understanding of how meshes are generated, and so like I ended up like pulling that script in and then talking step by step how that goes. But I mean, I guess technically I did start from scratch and then pull in code that I kind of modified. Was kind of the way that stream worked. But like, if you want me, yeah, I guess to build on that, that is something that could be done potentially. I'm not sure where I would take it, but I think someone had asked for like putting a UI on your hand, so we could do that. If hollow bulk, okay, wait, okay, now I need to look up hollow bulk. So many things to do, so little time. That's, but like there's just so many cool things that I wish I had an infinite amount of time to actually play around with. Oh, easy. The guy goes to easy? What are you talking about? Occasionally. Oh. Oh, nice. Yeah, we could do that. I think one of, what are, we could do this. One of the things that I was thinking about was instead of, I guess this is kind of a mix between, no, never mind, what am I talking about? It's the Lightblade VR that came out last week, I think, or this week. That, I think, would also be super fun. This is also looks cool. It's also pretty, yeah. Oh, you have to hit, wait, you have to hit the target? Okay, I just need to play this. Honestly, I feel like this is just something I need to play and then experience for myself. Movement in the lab. As far as just like teleportation, movement in the lab as far as teleportation, let me know. Actually, honestly, this might be easier just to talk in the chat. So I think I might just cut the cut the stream, because I'm like asking the question and then I realize I have to wait 15 seconds. So like that honestly might be just better to do in the chat. So I mean, yeah, we can. I guess that's more of a renderer technique, which we can. If I'm looking at the lab renderer, I think it's probably in there, and then we can use that. But yeah, I just have to take a look at it, which I can definitely try to do. These are all definitely like really great topics to go over, because there's so many topics to go over, that's for sure. Let me go ahead and save that and close that. But yeah, I'll stick around in the chat for however long we need to, and I think we'll keep that conversation going. But yeah, just you can, I mean, if you want to see more of this stuff and like get notified about things, like just subscribe to the channel or follow us on social media. I just keep posting a bunch of stuff and just keep trying to get the word out as much as possible. Like, I mean, mention this to your friends if they're interested, and I mean, I'm always just like looking for feedback on more stuff that people want to learn about, and that's just gonna kind of see what people want and then go from there. But yeah, let's just keep talking in the chat, and I'll see you guys next week. This has been FuseMan. I'm signing out. Sort of, kind of. Once I hit the stop stream. See you guys.